Okay, so hi everyone, I'm Barak Tawily, and I'm going to talk about exploiting web messaging implementations. So first of all, who am I? By day, I'm the co-founder and CDO of Enzo Security. We are developing an ASPM, Application Security Posture Management platform, in order to help AppSec teams to manage and automate their scalable application security program. By night, I'm application security researcher, bug bounty hunter, and blogger. You can check my blog for the interesting researchers and the findings that I've done. And I'm the author of Authorize, which is the burp extension, the most popular burp extension for automatic detection of authentication and authorization flaws. This is a project that I'm a contributor for years. And if you're not familiar with it, I'm highly recommending using it. So what exactly are we going to talk about? We're going to talk about what is cross-document messaging, cross-document messaging security model and weaknesses. We're going to see my hacking methodology and some real-world use cases. We'll see Pasta, which is an open source tool that we are developed in order to find such flaws, and we'll go through the best practices in the end. So what is cross-document messaging? Cross-document messaging is the actual ability to send and receive messages from one window to another. Now, as you can see in here, we can see that we have alice.com, which holds a window, and we have another window that's hosted on bob.com. We can see that alice.com sent a message to bob.com saying, "Hi, Bob." Bob received the message, processed it, and sent back message to Alice saying, "Hey, Alice." And basically, so this is it. This is just the ability of two windows to communicate with each other. There is no network involvement. It is all happening inside the browser. It's in-memory communication, and there is no involvement of any networking at all. So we're not going to talk about HTTP at all. Now let's understand how we are going to receive a message. So first of all, let's understand what happened inside the browser. So we have the browser. It has its own tabs. Each tab have a region. Each region contains windows. These windows renders a document, which we have, and in this document we have scripts. Now these scripts can actually have the ability to receive message. So basically, in order to receive message, we'll need to add an event listener into the window object. So we need to use the window.add event listener with event type message. So we will be able to receive the message and handle it. Or we can use the window.message, it's just a synthetic sugar for that. Now, as you can see in here, so when we are implementing a listener, we are actually getting a message event. The message events contains some properties. The most interesting properties are the data, which contains the actual data that's sent from the sender into our window, and the origin, the actual origin that sends this message. And we will elaborate it later on. So this way we can easily receive messages. Now, in order to send messages, we'll need to, first of all, get a window reference. Now, in order to get a window reference, we can use two different ways. We can embed an iframe, and as you can see in here, we have a code example that is actually creating an iframe, setting the source attribute as the website, that the page that we would like to communicate with. we see that we are appending this iframe into our body. Then we can use the iframe.content window in order to get the window reference. So this will be used later on. So we'll be able to communicate with. Now, another way to do that is to actually pop up a new window or tab using window.open in order to get the same window reference. So once we are getting this window reference, we can actually use the window.postMessage method in order to send message to this window. Now, the postMessage method receives two arguments. First is the message. It can be string or just an object. And the second is the target origin. Now, the target origin allows us to explicitly declare of who is the target origin and who should receive this, which origin should get this message. Then we can tell the browser, okay, this message needs to be sent to bob.com. And the browser will ensure that bob.com receives this. Now, so if we're trying to simplify, cross-document messaging is the ability of two windows to communicate. So let's see the most simple example in here of two windows to communicate with each other. So on the left, we have a window that hosted on alice.com. We can see that it used window.open in order to get the window reference to bob.com, and the browser will pop up another tab with the bob.com page. And we can use the window reference .postMessage in order to send the message, hey Bob, to bob.com origin. Now we can see on the right side that bob.com code is actually implementing an event listener to handle messages. And what it does, it uses the window.opener in order to get a window reference to the origin that opened it. In this case, it's alice.com. Then he sent a hey Alice message and passed the target origin alice.com. This actually sends the message back to Alice. So this is the most simplified way to describe cross-document messaging. Now, let's understand the cross-document messaging security model and its weaknesses. So basically, we have three components when security feature can be implemented. We have the sender code that can apply security inside the sender code, the receiver code, and the browser feature that allows us to set some headers in order to avoid risky situations. So let's understand the sender code security model. So the sender code must specify the target origin. Now, the target origin can be used via the value wildcard, saying that there is no preferences of who should be the recipients, and then basically any receiver that will listen to messages will be able to read this message. Now, in here in the MDN documentation, you can see that they are saying always provide a specific target origin and not a wildcard. Now, we see many times when developers are using wildcard. It is happening, but usually because there is many cases when it might be hard for the developer to understand explicitly the target origin. We see some implementations that target origins passed via parameters. We see that many cases when wildcard are using, and I think the main reason for that is that developers needs to support multiple use cases and multiple origins, like subdomains. Maybe they have some whitelisting, and they have to communicate with multiple target regions. Then developers might use wildcards or any other insecure implementations. And we will see it later on the use cases slide. Now, let's understand the browser features that allows us to avoid some risky scenarios. So we have three headers: the cross-origin opener policy, the cross-origin embedder policy, and the X-frame options. Now, they are all can be used in order to avoid some scenarios, and it's not really a holistic one. Let's say, okay, so the cross-origin opener policy allows to specific origin not being able to use window.opener inside on your domain. The embedder policy and the X-frame option is actually allowing you to avoid being embedded inside another scenarios, but each one of them can be bypassed. We have window open and we have iframe, so it's not really holistic enough. And I think specifically on cross-document messaging implementations, they have some, but usually it's a front-end developers. They might not be able to write a backend code, so they won't be able to add these others. And there are many cases when it might be tricky to use this. And I think that this is why I think we see that there is no many scenarios when we see these headers. In fact, except for X-frame options, that is usually being used in order to avoid clickjacking attacks. The receiver code security model is actually that the developer is receiving the actual event origin, and he needs to authorize each origin and each message that he gets. We can see in here that we have this code that is implementing the listener, and we can see that the developer checking if the origin of the event equals to example.org, and in case it's not, it won't process the message. In case it is, it will continue to process the code. Now, the issue in here is that in many cases, you would like to, you are running on different environments. You have some multiple use cases that you need to support, maybe multiple domains or maybe subdomains. So you will see a lot of weird implementations around this domain origin verification, and we can see many developers making a lot of mistakes. They are making regex checks and some weird includes, and like many implementations that can be bypassed, or the developers are just skip the authorization and they are not implementing these checks at all. So it might be really tricky for developers in order to actually write this and implement this authorization flow. So let's talk about the potential weaknesses. So we have the sender code. In the sender code, we have spoofing. It might be vulnerable for spoofing because he might not be aware of who exactly it is going to send their messages to. So the sender code might use wildcard or might implement it insecurely the target origin, then he might send the messages into recipients that didn't meant to get this message, and it could be potentially malicious. Then he will be able to, he might cause sensitive information leakage. On the other hand, we have the receiver code that is actually vulnerable for spoofing as well, because he might receive some messages from senders that he didn't mean to receive this message from. They might not implement the origin verification properly, or might just skip and just not implement it. Then we will be like the attackers will be able to spoof and actually send messages into these receivers. And then we have the tampering, which so the actual payload that's sent from senders might manipulate the code in the receiver and abuse its functionality and cause XSS, CSRF, open redirections, logical flaws, denial of service, and many, many more. It depends on the actual implementations. So let's see some attack examples. We can see that we have we can attack senders to eavesdrop sensitive data, and we can attack receivers in order to abuse the remote functionality to do malicious operations. So let's see some example of vulnerable sender code. So we can see on the left we have the targeted .com region, and it implemented this script. This script is actually calling an SSO authenticate call. This SSO authenticate function is actually used in order to generate an access token to authenticated user. Then what it does, it uses window.opener to get a window reference for whoever opened it, and send a message with the access token and the target origin specified as a wildcard, which means that any recipient can receive this message, and it sends obviously the access token. So how exactly a malicious code will look like? So as we can see in here, the malicious code is actually, first of all, implemented a listener to receive messages. Once Handy used save event message to DB function that is actually saving any message that will be received into this listener. They will save it in the attacker's DB. Then he used the window.open in order to actually open up a new tab into the targeted website page. Now, the targeted website page will execute the SSO authenticate, will generate the access token, and will use window.opener .post message in order to send the access token into whoever opened it. And the attacker will be able to receive this access token and take over the victim's account. Now, let's see a receiver code weakness. So in here we can see we have Bob.com. Bob.com implemented a listener. This listener is basically might implement an authentication, maybe not in this case. The implementation is that, as you can see, that the developer checks if the event origin includes the string .bob.com. In case it is, he will pass. In case it's not, he will not process the message. So basically in here we can see some implementation that is vulnerable, that is trying to say, okay, I will allow only subdomains of bob.com to get processed at all. Then in case it is, so we are using the document, the developer used the document.location in order to redirect the user into the return to parameter that received inside this event message. Now, how the attacker can actually bypass it. So we can see in here, the attacker used test.bob.com as a subdomain of the his own malicious.com domain in order to pass the previous insecure implementations that just check in if the origin includes .bob.com. So it is, and it will pass this authorization check. Then what he will do, it will just use a window to open in order to get a window reference. He will create a payload with the return to parameter that the user will be redirected to it. Then we actually in here see that the attacker used JavaScript in order to redirect the user again. So basically the attacker can execute JavaScript on the behalf of the vulnerable website, and he used it in order to redirect the user again into his malicious page, and it appended the document cookies of the victim in order to steal the victim's cookies and save it later on and take over the victim's account later on. Then he just used the window ref post message in order to send the payload to the relevant origin. So basically we can see in here that we have the ability, so we pass the authorization check, and due to insecure implementation on the receiver code, we saw that we can abuse it in order to run JavaScript and take and steal the victim's cookies. Let's talk about the key weaknesses. So cross-document messaging weaknesses are that by default, Windows can get a window reference and send post messages to whoever they want and in between to each other. Developers have many responsibilities, and with many responsibilities comes many mistakes that might occur. And on the receiver script, there is no authorization, default authorization, so developers needs to implement their own authorization checks. In sender scripts, we have the ability to use wildcard and not explicitly declare on a specific target origin. And we can see in many cases when we are running on a different environments and when we needs to support many use cases, whitelisting, subdomain whitelisting, and many other cases, it is being really tricky to actually explicitly determine who should be the sender or the receiver. Now let's talk about the hacking methodology. So first of all, we'll need to identify the potential targets. Now the potential targets are quite simple. They are any window that listens to messages and any window that can send message. Now let's go and drill down to the attack flow of each one of them to understand how the flow is looking like and what you need to identify in order to find such vulnerabilities. So let's talk about the listener attack flow. So first of all, you need to do is to actually look for code that implementing listeners. Now you can do that via developers tools or any proxy tool or any other tool that is allowing you to look for strings inside the targeted website code. So you can do that via like look for window.on message string or checking if they have window.add an event listener with event type message. Now, once we're having this, you will see a huge sorry, amount of listeners, and after that, you'll need to check if they're implemented the proper authorization. Now, you're going to see a lot of use cases when maybe the authorization at all is not implemented, or you will see a lot of cases when you will see regexes and some weird statements, and maybe sometimes you will see that you are getting some parameters, and you'll see a lot of weird implementations around the authorization, and you'll need to investigate to understand exactly if the authorization is properly defined and if it might be bypassed. We will see in the next slides real use cases of this authorization flows. Then you'll need to check if the code can be abused. So even if there is no authorization check, maybe this listener do nothing, and you will need to understand exactly if it uses some risky functions, like, I don't know, like creating some elements and doing some DOM manipulation, maybe some redirects, or there are many use cases that might be manipulated. It depends on the actual implementation of each specific listener. Then you'll need to get a window reference. So you will need to understand if you have the ability to get a window reference. In most of the cases, yes, maybe you have some restrictions. Then you will need to write the actual exploit. Now, writing an exploit can be quite problematic because you'll need to understand exactly how the custom protocol of the receivers are happening or are implementing, and how exactly the payloads needs to be sent. And you will see a lot of weird protocols that being used. So it might require drilling down into the actual messaging protocol, because it's sometimes it's just simple string, sometimes you'll see a lot of weird implementations around it. So it might require a further investigation and drilling down to the code. Now, let's talk about the sender's attack flow. So same as the previous slide, we'll need to look for post message method usage. Same, we can use a developer's tool or any other tool to do that. And then you will be able to see all the post message column. Now, sorry. Now, then we'll need to look for sensitive messages, because if we are like, this is what we are, when we're talking about the sender, we'll like to receive the sensitive messages from the senders, and we will be the receivers. So we'll need to go to understand the the application flow in order to understand if the messages are sensitive. Maybe there are some token passed, maybe there are some parameters or any other sensitive data. So after we understand that we have the post message, we realize that it is used sensitive data, then we'll need to analyze the target origin implementation. So the easiest way is like if we have a wildcard, but you will be surprised to see how many weird implementation we have around that as well. Sometimes, in many cases, there are some parameters that passed in order to be able to support multiple domains, and you will need to understand exactly the actual protocol and if the target or region implementation can be abused or bypassed in order that you will be able to receive the message. Then we'll need to write an exploit. The exploit, again, can be, in this case, can be really easy because we are just implementing a receiver and needs to maybe use some manipulation around the target or region implementations. But sometimes you'll need to sorry, to get a window reference, because sometimes when you want to reach the sender code, you will realize that you might need to send a message in order to reach the exact code in order to trigger the other post message. So basically, it might optionally you might need to get a window reference in order to send the message. So to trigger the other side to send the sensitive message back to you. Now let's see some real-world use cases. So we have an insecure region verification on a really big ad tech company that I cannot expose now, that this is used in order to perform some. This allows us to perform some read-write local storage, CSRF, XSS, and read the vulnerable the victim's cookies. We have another big payment provider that was exposed to information theft, that we had the ability to read and write session storage and perform CSRF. And we'll see AliExpress sidebar takeover that end up as an XSS. And let's go and drill down for each one of them. So in here we can see the insecure origin verification. So basically we can see the actual implementation of the code of the listener. So we can see that they are implemented listener. We have the pass data parameter that use the handle JSON, which is passing the event.data into this handle JSON param with the handler parse. And let's understand what's happening in the handle JSON param function. So we can see it have some input validation checks, and it checks in case the handler is parse. Is just validating if the args.data, which is controlled by us, which is the actual event data, is a valid JSON. In case it is, it will parse it and return it back to the pass data parameter. Now, in here we can see that we have some verification. Let's understand what is it. So we can see that the developer checking if the document referrer is starting with the event.origin. This is the first statement. If you ask me, I don't know why the developer actually chose to implement it that way. But basically, this statement will always be true due to the fact that if I'm embedding some window or using window open, so my malicious origin that will send a message to this listener later on will always, so the statement will always be true, because I will be always the referrer of this document because I am the one who opened it. But let's ignore it and let's go and see the other statement that, so there the developer checks if the document referrer is empty string and if the origin is null. Now, this can be bypassed as well. If you would like to elaborate and get more detail around the original attacks, you can check my blog, and I have some article describing this attack. But basically, we can use iframe source docs in order to fake this original domains, and we will be able to pass this check as well. And so this is bypassable as well. And we have the last statement that's checking if pass data exist, and if pass data.null sent from BSDK is true, and in case it is, it will go and pass this check. And obviously, we are controlling the pass data, so we have the ability to bypass this check as well. So basically, these three checks are bypassable, and let's see what the rest of the code allows us to do and how can we abuse it. So in here, we can see that we have some checks regarding if storage type exists, and in case it equals to local, we'll pass and go through this code. We see we have some switch case regarding the event type, and in case it equals to get, we check that the developer checks if the local storage exists, and in case check another weird origin check for its own page, which will always be true. Then we can see in here that the data is equals to local storage.getItem, and with the paste data.key, which controlled by us. So we have the ability to retrieve any key from the local storage of the targeted website, and we see that they used toss message in order to send the value back to the actual sender. You can see we have this, in case the event type is set, we have the ability to actually set an item into the local storage, and we are controlling the key and the data that will be inserted into the local storage, and we can delete and remove item from the local storage based on a key. So basically, we have the ability to full control the local storage, rather than if it will be read or and write of the local storage of this targeted page. In here, we can see that same checks for storage type, and they check in if it equals to cookie. Here we can see that in case it is the event type is get with the storage type cookie. So in case the passed key will be equals to cookie all, we will be able to fetch the cookies of the victims, and they will send it back to us as the attackers. So we have full control on the not full control. We have the ability to read all the cookies of the victim. Now, in here, we can see another code, which is the same code. They're all is the same part of the same code, and we can see that we have some checks. If we have pass data.data and its data have a URL, and in case it is, we can see that we have some additional event types for muskref and muskref retry, and basically we are controlling the data URL, and we are able to perform CSRF attacks on the victim, because you can see that they are calling send request and fire to URL, which allows us to actually send requests on behalf of the user. Now, the most interesting one is the recusing frame, the third case, and we'll see that they are calling this send recusing frame function, and let's go drill down to that. So in here, we can see that what the developer do is to receive the URL, which is controlled by us. It create an element, an iframe element, and it sets the URL as the iframe source. We can see that it's invisible one with no height and width, and they are appending the iframe to the body. Now, this allows us to be able to use JavaScript as the URL in order to actually perform actions within the same context of the target origin. Because when you're using iframe with a source of JavaScript, it just receives the same origin context. Then we are able to do whatever we want on behalf of this domain and run any JavaScript. So we can set some cookies, we can steal cookies, we can do whatever we want. And as you can see in here, we have a window reference pass message. This is just an example of the actual exploit. So we see that we passed no sent from BSDK true in order to pass the restrictions. Then we use the event type recusing frame as we saw earlier, and we pass this data as a JSON object that contains a URL, and this URL is actually a JavaScript that can run. So we are able to run any JavaScript on behalf of this targeted website. In here, you can see another example of the ability to read and write session storage. This print screen is actually a alpha version of the Pasta, the research tool that we developed that we will see in a few slides. But what we can see in here, so we can see that we have local storage, which is one origin. This is the malicious website. And we can see we have the targeted origin on the other end. And we can see a message sent from the malicious site into the targeted website. We can see that he passed a string with type storage, action get, and some key in order to. So we investigate the actual implementation. We see that they have this protocol, they passing these JSONs, and they need to receive a type of storage, action, and the key. And then we can see the next message that the vulnerable website sent to us back a message after we sent him a message to please give me this session key. We can see that the type, so we send back a message with the type get storage. We can see the key with the session key, and we can see the actual value that we retrieved from the victim. And then we can use this value in order to take over its account. In here, we can see another use case that is simple implementation that in case we are opening the actual page, and the actual page is loaded and it sends to its window opener this message, and this message is actually have this data. You can see that the action is after init. So after an initialization of the page, this message is sent to us. All we needed to do is just to have a window list, an event listener to receive this message, and we just log them into the console. And you can see in here that we have some data regarding the user, and the most interesting one is the actual CSRF token that we could use in order to perform actions and bypass the CSRF protection mechanism. So we had the ability to perform actions on behalf of any user that will browse into our malicious page. In here, we can see the AliExpress sidebar. You can see that, so I was browsing AliExpress. I saw this, I was intercepting the messages. Then I saw that we have this, I saw some messages contains this, the values of, as you can see in here, in the sales sidebar. They had some different origin that they are embedded as the iframe, and they communicate with them in order to fetch the list of the sales packages or whatever. And what we did is to actually, we went drill down to the code and let's see what happened there. So basically, we can see that they used their own listener wrapper with this messenger, the store proxy, and they set up some, they have their own setup for cross-document messaging. You can see that the messenger.listen is actually a receiver. Then you can see that they are use the SPE2C and this value in order to split some operation with keys and values, and they use their own weird implementation that the dash underscore dash is a separator, and they used it so this is like their own implementation for their own communication protocol. Then we can see on the right that in case the operation is set, so they will use this store, which is in this case the local storage, to set a key and a value, which is obviously controlled by us. We can see that we can get the store values, or any value in the local storage, and we could remove these keys. So let's see the actual exploit. So after drilling down and understanding the actual messages and their own proprietary protocol, we used store dash. So the payload looks like store dash proxy, then the actual operation, which is set in this case. Then we have this this separator with dash underscore dash, the actual key, which is the big promotion category list object. Then we have the separator again with dash underscore dash, and the malicious object that is controlled by us. We loaded an iframe to the vulnerable page, and we used the exploit. We waited just a half of a second in order to send the message, so the iframe will be loaded. Basically, this is the most. This is just an example of how exploit can be written. So any user that will browse to it, it will rewrite its own big promotion category list inside the local storage. And we can see in here that we have that we actually executed this attack, and we can see that the big promotion category list object controlled by us. You can see that we changed the title to hackers and hobbies. We could change the icon or the URL. And the URL is actually can hold JavaScript. So basically, once the user will click it, it will trigger the malicious code. So
so hey,
what
Barak,
we just to serve this exploit page. And So once the victim browses it, it will inject the
Hey, Barak, just looks like it's cutting out right now at the moment. We're into our just a 10-minute warning kind of thing, and I had just a couple questions. And if you had something you could spin up real quick,
Okay.
well, you let me know.
Yeah. So, would you like me to continue or?
Yeah, we just have two questions. One's a really simple one, like will these slides be available post talk? I'm guessing they can hit it up on your blog on Quentin. And then the second one was kind of just talking about open messaging applications being used as an avenue to business infrastructure. Is that something that you see?
Sorry, can you repeat?
Yeah, so like the question is, can open messaging applications be used as an avenue to business infrastructure? So
yeah, so if I try to like business infrastructure, usually we can see a lot of implementations around like third-party apps, and in many infrastructure of infrastructure, you can see website builders and many other cases when you can see these implementation. A lot of advertisement around implementations. Yeah.
gotcha. And just a question on, I see your slides, a magical research tool. Is that an open source product that you're
Yes, I didn't had enough time to talk about it, but yes, we as you can see in the presentation, so we basically managed to develop a research tool named Pasta. So we looked for in other implementation of such a research tool. We didn't see any satisfied and really professional one. And we wanted it to be able to see senders and messages, to see the receivers in the messages, and to be able to actually simulate malicious sender and receivers. This is why, like me and two other guys, Chen Guraria and Omer Yaron, my colleagues, we managed to develop it together. It's basically just a simple Chromium extension that you can just install on your Chrome. It has the ability, so it intercepts the entire tabs. It gives you the actual hierarchy, as you can see in here. We have the Enzo.security, and we can see the actual messages that sent to it and received. We can see the hierarchy and go and drill down for each tab to understand exactly what kind of listeners it implements. So we will be able to see the listeners on the right when you can see now the message. So you will be able to go and investigate the actual listener to see if they have authorization in place, etc. And you have the ability to see and receive messages, to see incoming messages and outcome messages, as you can see in here. So you can simply see that the first message was incoming from vars.ojar.com into enzo.security, and you can see the response of Enzo Security in here. On the right button, you can see you have two buttons, one for actually replying and reply requests as you wish, and we have the simulate exploit, which is another page that allows you to actually test an exploit for senders and receivers in order to be able to actually test your exploit in the most efficient way.
Very cool. Are there any other projects you and your team are going to be working on?
I have
or
my
own. Yeah.
I have my own authorized burp extension. I understood from Portswigger guys that it's one of the most popular burp extension, and so happy about it and helping the community. So I'm highly recommending everyone to check it out. I know it's pretty popular in the AppSec world, but if you're not familiar with that, you have to. Yeah, and if I would, can I go through the best practices maybe?
Yeah, good. Sure, go ahead.
Great, cool. So basically, two of the most important things regarding cross-document messaging will be to always declare and define explicit origin target when you are using post message method, and never use wildcard, and will need to be really strict about that. And the second is to actually, when you are receiving messages, make sure that you are having the verification, the origin verification mechanism. We should, like, it is really crucial, and I see a lot of implementation when developers are not aware of it, and they are doing a lot of mistakes around that. So that's the third point. So you have to make sure that your developers are actually know to actually write a proper verification mechanism, because we can see a lot of cases. Maybe most of you know it from open redirection attacks, when the developers might implement some restrictions, but they are actually easily bypassable, and it is super important for them to be able to know and share this knowledge, and in order for them and you to have a proper origin verification. The fourth point is regarding the headers. To be honest, like, it's always welcome, and it's good, but it's the headers, the XFO headers and the cross-origin policies, they are not really holistic. So as I said, like, the two first points are the most important, and I'm highly recommending you to challenge it.
Awesome. Well, thanks, Barak. I guess they call you the Cookie Monster, probably. I really appreciate your presentation. It was really informative.